here, Ri3D Redux, back in a new location today. We're in 2041's build space. Thanks for letting us use that. Anyway, we've gone through 3 days. We've got 2 robots here. Both have a ton of issues, but are great for showing a bunch of concepts. You can kind of get an idea about how the field elements interact, how products interact with the field elements, things that get working. We'll try to go through some of those things that we think we could do, teams could shore up and do a little bit better as they do things themselves in the coming season.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in scholarships. Scholarship applications for FIRST students are now available. Get more information at kettering.edu/first. Stryker is one of the world-leading medical technology companies and is driven to help make healthcare better. Stryker's commitment to innovation has made it a career destination for engineering professionals. Click the link in the description box below or go to careers.stryker.com to discover your next opportunity.
Before I start, I want to make sure that we thank our generous sponsors and supporters with this. There's a lot of people that this couldn't have happened without. We probably had somewhere between 20 and 25 people come in and out for building. We've just got a subset of the team here today. It's from a wide variety of teams. There's I'm looking at the back of the robot. We probably have 12 team logos on there. So we got a whole bunch of people from all over coming out to help with this. So we really appreciate your support with this because it's a big deal. Can't forget to thank our generous sponsors as well. We have the Thrifty Bot, Andy Mark, Rev Robotics, Swerve Drive Specialties, Playing with Fusion, AJR Brands, JH Benedict, and obviously First Updates Now. Thank you so much for coming out and helping us out with this. It is a huge support in order to make it so we could do this and get 2 robots and show lots of things. So that's cool. Okay, so we're going to start with the Robot 1. So this robot has Swerve Drive Specialties chassis. We've got an elevator with some of the rev extrusion powered by a Max Planetary. Neos all over the place in here as well. The elevator, it's got a mix of Thrifty Bot and Andy Mark products in it to lift up. And we've got an arm that's also powered by a Max Planetary to drop. With a gripper. We've got some Andy Mark wheels, lots of Thrifty Bot bearings and hardware everywhere. We've got a Playing with Fusion time of flight sensor to detect if the game piece is collected. So let's go ahead and run this robot, and we'll pick up. Let's start by picking up a game piece from the floor over here, and then going ahead and scoring it. It can do upright cones only from the floor. We did practice a little bit of writing earlier. It's a little bit slow. So when we intake, let's see if we can go a little faster next time. So it's going to go ahead and take the game piece over to score it. We're going to score it on the 2nd level. So that one we need to drop the arm a little bit. Let's go ahead and try that again. So you can see there's a lot of software automation that needs to be done on these robots. A lot is being done manually right now. So we can actually put the cone. Oh, there we dropped it on the floor. Luckily it landed upright, so we can pick it up again. The gripper needs to be a little bit tighter. So if you pursue one of these grippers yourself, it would be good to work on that. So we're actually going to completely cover the stick as opposed to, just dropping it. Yep, there we go. Good job. Yeah, so if you completely get the cone around the stick like we did that time, it works a lot better. Now let's get a cube off the ground. Oh, like we said, we need a little more grip around the game pieces. Drop the arm down. Drop the elevator down and the arm more flat. Thank you. Pick it up. Gripper's going backwards, I think. Oh, there it goes. All right. So we got a better grip this time. So we're going to score this on level 3. Got to have it lower. We're going to try that one more time. All right, there we go. So you can see what this is capable of. We'll go to the feeder station over here now and pick up a cone out of the feeder station. Right? All right, go score the cone. Elevator needs to go down. Thank you. So with a little bit of software automation and shoring up some parts of this robot, could do a little bit better. The arm joint is also a little rough. We, if we were doing this longer, we definitely shore that up. And the elevator definitely needs to go up in order to reach level 2, as you can see, because the arm's not quite long enough to do it in just raising up a little bit like that. All right, we're going to do a cube out of the feeder station. How's battery? All right. We put it on level 2. All right, thank you. See if you can go up the ramp with this battery. Oh, we might need to switch batteries before we can go up. Here, let's give it a shot. This is a really rough battery here. All right, we're going to stop. What? Oh, do we have a question? All right, let's stop for a second. All right, stop. Let's swap batteries, and then we'll do this robot. Okay, we're gonna swap batteries, and then this robot's gonna go up on the platform later. Now we need we're gonna run this robot over here. You guys ready to run this one, please? Yep. All right, so we're gonna run the other robot. So this robot has a intake out the front. We used a lot of 80/20, so it's kind of, still a little bit in prototype form, but we wanted to make sure it got on the robot. It's got a bunch of ThriftyBot and Andy Mark wheels on it for picking up game pieces off the ground. We've got a clamper pinchy claw up here. Yep. So it's on a arm elevator. The arm is powered by a Neo with a Max planetary on it, and then the elevator is also a Neo with the Max planetary. We've got a the extrusion that we've got here. We've got this ThriftyBot telescope and climber for extending and retracting. Can you go out? Looks like we might be a little bit jammed here.
The motor controller spins itself again.
All right, question from chat from Shallon. Do you think that picking up down cones is worth it?
That's a good question. It depends on what level of play you're at. I think at Worlds it probably is. If you're talking about at a regional or district level, that depends on what regional or district you're at. Yep. All right. Could I someone take a look at this? Well, we'll go back to this one. Okay. So on this robot, we're gonna go ahead and glide it up on the platform. Yep. So you can see, pretty smooth. Again, that's the Swerve Drive Specialties modules. We've got the bumper about 1.5 inches off the floor. What? Yeah. 7, anyway. So looking over, are we able to run this robot again now? I guess we'll make a quick adjustment on that. Go ahead and play with this robot a little bit more, and then we'll come back to this one. There we go. That's a much better. Yeah. So you could see one of the things that we changed from the prior iteration here is, can you bring the arm up for a second? Yeah. So we doubled up on the surgical tubing. I'm looking at this now and kind of debugging on the fly. I think it's a little bit tight. So I'm going to pull one of these off, and this will be the configuration that we had earlier, and we'll see if it does better with the gripper. So a lot of lessons learned here. Obviously, we're tweaking variables on the fly. Some stuff makes it better, some stuff doesn't. I think one of the things that we've learned here, especially, is picking up cones off the floor when they're sideways is really tricky for a lot of things, and you just kind of have to play around with whatever you're doing, iterate on it a lot, and slowly you'll start tweaking out the bugs. Okay, so we got the other robot working. Let's go ahead. Why don't we pick up some stuff off the floor, and then we'll see if we can grab it in the gripper. You can see we have not worked on debugging this handoff much. There's a lot of work here still to do. But this robot can do quite a bit of things. It can score on every level for all the game pieces. It does have to be backwards. I think you have to go backwards. Yeah. Yeah, it has to go overhead. Now, when you're doing this in actual competition, you'd need to retract the telescope in order to be within size restrictions. The robot is capable of picking up with the pincher grabber and also the intake roller, obviously. But the intake roller, we don't have a good handoff working between the two, so we're just kind of like, swagging it right now. Go ahead and grab a cone. So this one, we're having the pinchy grabber grab a down cone. It'll pick it up. It automatically, gravity gets it into position. The telescope can extend. And then it drops over it, and it drops. Can you use the intake to pick up a cone?
right, question from chat.
Okay, so there's a little bit that needs to be debugged with the intake in order to get it in the proper position. Yeah, so, yeah. We're going to intake a cone a couple times. So we weren't able to do it in 3 days, but for teams, if you can get it so the cone can get in the long orientation, then the pinchy grabber in this particular case could reach into the robot, pick it up, and put it in the right position. So I'm going to manually move this cone right here so that they can get around it and pinch it. Then we're going to, it flips around the back and they can go score it. We're going to go to the feeder station now and use the pinch grab to pick up an item out of the feeder station. All right, that's good. All right, so you could see there's a lot that is obviously still being worked on. Essentially, there's a lot of things that if you built for an actual robot over the course of your season, you'd want to get shorn up. But from a concept perspective, with a little bit of alignment, the pinchy grabber works pretty decent. You just need to. There's lots of considerations in terms of forward, back, and things like that that you'd want to worry about that. I think ultimately it's going to be a little bit slower than touch and grab, but there's you could make it work if you wanted to make it work. Essentially, it's pretty simple. So I think we're going to go ahead and head over to questions now, and we'll start covering some things on the robot, and I'll call on the team, or if the team has wants to give a particular answer, feel free to speak up, and I'll hand you the microphone.
So let's actually start the voting for the robot names.
Okay. Yes, we're doing that.
We're going to run
That's
a
cool.
10-minute poll for everybody. So let's name off once again what the names are. We'll go through there. So here are your choices. They're going to pop up on screen if you're in Twitch chat. You got Shrek and Fiona, Simone and Pumbaa. Sorry, I got to view these back up here. Pumbaa and Timon. Sorry, Simone. Pumbaa and Timon, Meow and Wolf, and Kool-Aid Man and Mr. Peanut. And we'll have to figure out which one is which. So vote in Twitch chat, and we're also going to start a giveaway from Andy Mark in just a little bit as well. So get those questions in. We're going to have Samantha field a few questions in just a moment, but we'll get the poll going during that time.
All right, so first question from Travis48. What is the height of the robot when the arm is retracted and fully vertical?
Jack, I believe it's 6'6", right? 6'6" is the max height. Yes, so it is the max height when it is retracted and fully up.
And what material are we using for the gripper?
Yeah, it is like it's drawer liner from one of the drawers in my house, I believe, right?
I'd say a good alternative to the drawer liner would be neoprene, and then 3M has a really good epoxy that works with neoprene to aluminum that they should run probably. And you can look at, maybe you could scuff up the aluminum to make sure you get a good cohesion. I guess it works as a cohesion where you would put it some glue on the aluminum, and then you put some glue on the neoprene, and you push it together. And I would say that would be a more permanent solution that you can buy on McMaster.
All right. Another question we have is from CryptoRex. Potential strategies you thought of that will work well with these bots.
Yeah, so a lot of these robots are kind of built for essentially feeder station running. They might be the bottom one, or this one right over here, Robot 2. If we got the handoff working, you could do it from the drop-in intake station, the one that's a little bit closer. The one over here, Robot 1, I think you're pretty much stuck pulling from the shelf, essentially the shelf feeder station. But yeah. What do you? Oh, this one. Yeah, one of the things that we were playing around with was we were going to drop a cone into the hopper of Robot 2, so we're going to go ahead and do that real quick, just to see how that works. If we just line up the intake right there, yeah. So it bounces around a little bit. So you could feasibly play around with your own with your drop-in feeder station with something like this, and try to make it so it got in a configuration that worked for you. We don't have the time to do it for 3 days, but you could do a hopper drop if you wanted to, and then a grab, like maybe put a trash can on there to make it slide nicely or something. But anyway, that's something we didn't have time to do in 3 days, so you'll have to explore it yourself.
All right, and we've got a couple of questions about potential design improvements on this. So 2 of them. First off, from Juxie, maybe behind the front rollers, there are side rollers to center the cone for the gripper. And from Silver Lightning, or perhaps polycarb guides at an angle to guide the cone as it enters the intake.
Yeah, those are 2 good ideas. We didn't have time to do either of those, so highly suggest you have your teams do it.
And that is all the questions for the moment.
All right. Yeah, I mean, I would say both these robots are a little bit rough. I think in general, doing things in 3 days, it's good for getting a lot of concepts out there. I wouldn't wholesale copy either of these robots. You got a lot of issues that we got to work out here. If you like a particular concept, do you think it showed promise, try it out yourself. Maybe try to make a version that's a little bit better. Neither of these robots are gonna, in their current state, gonna be winning competitions or anything like that. So you want to, look at them, take what's interesting, and then work from there. Essentially, hopefully, we've had some very interesting things that you've been able to see with the game elements and things of that nature. That would be good. I do think, have been impressed with all the products that we've had from the sponsors. They've worked good for us. I think it's more just everything takes a little bit of time in order to polish it up in terms of performance of things like, for example, the Max Planetary. Like, those things have been a boss. The Neos have been great. The the Rev extrusion holding stuff together is great. All the products we've gotten from Andy Mark, like wheels and the elevator bearings from Thrifty Bots. The all of the Swerve Drive Specialties modules, especially too. The all the playing with fusion sensors that we've got here for the time of flights. Obviously all the hardware we got from Thrifty Bot too. All that stuff is like performed where it needed to. A lot of it's been more just installation issues and the mere fact of what you're able to pull off in 3 days, and we just didn't have the time to kind of churn the iterations enough to pull it off. So like a lot of the stuff that we've been using is great. I think everything just needs more reps and time and tweaking in order to get to be where it needs to be.
So, Ben, we got about 5 minutes left in our poll. That's going to be about as much time we take during this reveal. Let's start our giveaway from our friends at Andy Mark, who are giving away a official competition cube and cone. They're going to have the Andy Mark staff sign it as well. So if you're interested in winning that, be sure you are following the First Updates Now channel here on Twitch. We do give our subs a little bit extra luck. We just rig it that way for them. Type cube with an exclamation point. Cube. Get that in chat. Right now, that's your opportunity to win. And thanks again to Andy Mark for the awesome giveaway. We'll draw for that after the naming ends. we'll take a couple more questions, and then we're going to wrap up our stream here today and film our reveal video a little bit later.
All right, so question from Crypto Rex. What would you do if you had an hour more, a day more, and a week more?
If we had an hour more, we'd just play with them on the field here some more, and that'd probably be it. You know, if we had a day more, we'd probably be trying to shore up some of the mechanical stuff and doing maybe playing around with autonomous modes and the you know, more vision stuff and that sort of thing. If we had a week more, we'd probably be trying to polish up this handoff a little bit to show teams, you know, how you could pull that sort of thing off in a consistent manner. I think that's probably a decent summary. On this robot, I'd also replace this arm joint with something a lot more sturdy, personally. But between those two things, I think that's kind of the big items.
And from Shailin, would you make any design changes if you had to design around a West Coast drive?
If it had to design around a West Coast drive, I think that keeping the same approach for mechanisms works for that, because they're oriented in a similar fashion. I don't think that that's going to change too much. Yeah.
Maybe try and do a feature on your bumpers that help you passively align on the scoring stations if you're going to have an arm, so you can just kind of drive in and then not necessarily wedge, but help center your robot on the scoring features of the field.
I co-sign that. It's a little bit easier to do with swerve, so we haven't worried about that. But yeah, you might want to think about that sort of stuff if you're going with more of a traditional drivetrain. All right.
All right, rolling for the giveaway. All right, so our winner is Thunder Hawk Zoe.
Ooh.
Congratulations.
Great job. Yeah. So thanks thanks to the team for coming out here. A lot of people involved here. Really couldn't do it without you. It's like I said at the beginning of the stream, we probably had around like 20 to 25 people come in and out to help out, to pull off a lot of what you see here and show off a lot of videos and things that that hopefully some people at home found useful. Thanks as well to all of our sponsors. We got ThriftyBot, Andy Mark, Robotics, Playing with Fusion, Swerve Drive Specialties, JH Benedict, AJR Brands. Really super helpful. Thanks especially also to FRC's 2041, 1756, 1736 for space and resources and support that you've provided to help make this possible as well. Lots of borrowed parts and things of that nature that have really helped us do things. And you know, everyone's teams who let you you know, send your mentors out here to work on things for a little bit. That's been very helpful. Yeah, it's been a good Ri3D. Hope everyone's had a good time. Now we can get back to the normal build season, get some sleep, that sort of thing. Yeah, it's been a good time, and thanks everyone.
And we did have the winners, by the way, Ben.
Oh, yeah?
I forgot which one's which. So
okay.
I'm not sure what you think. But we had Kool-Aid Man and Mr. Peanut.
Okay. Yeah, that's Mr. Peanut. This is Kool-Aid Man.
Okay. So
yes.
Why is this one called Kool-Aid Man, Ben?
Yeah, we're not going to talk about that.
So
All right.
go back
Yes.
and watch the archives for that as well. But thank you, everybody, for tuning in. For everybody who has tuned in, check this. Sincerely, this R3 team has been absolutely incredible. The work they put in to get 2 robots out, to help provide educational resources for you. Make sure you go check out all the videos on Fun's YouTube. We still have more coming out as well, too.
Yeah,
so
there's quite a few, yes.
Yeah, and actually a really good one we filmed just earlier that's going to talk about and demonstrate field-centric versus robot-centric drive. We have video of the controller as well, too. So make sure you check that out as well. And other great content coming as well, too, from Fun. We're going to be working with the Open Alliance teams. We have about 80 Open Alliance teams who are open books on what their concepts, designs, process is going to be. That's going to be starting next Tuesday at 8 p.m. Eastern. You can tune in. We're going to have about 4 to 5 Open Alliance teams each week detailing what's going on with those teams as well. And, of course, other great content as we get closer to competition season. Make sure you check out Fun Show Calendar for all details coming forward with that. But, yes, thank you to everybody that's been here. Thank you to all the sponsors that have truly made this happen. Robot in 3 days is an incredible thing when done right, and I think the Redux team has done it right. So kudos to them. Kudos to all of you. Thank you so much for watching, and we'll see you next time on Fun. Thanks, everybody.
Thank you.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in scholarships. Scholarship applications for FIRST students are now available. Get more information at kettering.edu/first. Stryker is one of the world-leading medical technology companies and is driven to help make healthcare better. Stryker's commitment to innovation has made it a career destination for engineering professionals. Click the link in the description box below or go to careers.stryker.com to discover your next opportunity. Thank you to all of our suppliers and sponsors for the Robot in 3 Days Redux and Kettering Bulldogs programs.